Hello guys, my name is Yadi Kalsi. Today we are actually going to go over chapter number 4 for cabling media under C7 California low voltage contractor certification. So in chapter number 4, we are going to concentrate on cabling media and we are going to cover approximately 10 topics. One is the overview of the cabling medias, then the type of grades available in the cablings, category classifications, how do we categorize the cables. TP stands for twisted pair copper cablings. Number 5 is twisted pair patch cords. What does exactly it means? Number 6 is SCTP. So what I did is I have put S and the C is little small. It stands for screened twisted pair. Then number 7th is coaxial cables. 8 we are going to cover multiple optical fiber cables. Number 7th, it's a high pair twisted pair, means where you have a lot of pairs available in the jacket, what we call. And number 10th, we are going to cover about color coding used in the twisted pair or other type of cablings, but mostly twisted pair. So let's go over these topics. First of all, let's try to cover let's try to cover the overview of the cablings. I'm going to remove this because this is not relevant anymore.
What is relevant?
So what we are going to do is let's try to cover what is overview of the cabling. So you will hear in this particular certification, you will hear a lot of terms like ANSI, TIA, EIA, and some numbers associated with it. So before even we go to the overview, or as a part of overview, we can actually discuss that. What is ANSI stand for? What is TIA stand for? What is EIA stand for? And there are some numbers like XXX, A, B, C, and other things. And most of the time, what you will see is they are listed listed as one word itself. What I mean by that is it says ANSI / TIA / EIA / for example, in this case we call it 570A. So don't get confused with all of these like complex terms. It stands it's pretty actually easy to understand. So let's talk about what is ANSI stand for. It's a fancy institute we called as American National Standards Institute, nothing else. So ANSI stands for American National Standard Institute. What stands TIA? TIA stands for Telecommunications Industry Association. Then we call EIA. EIA stands for Electronic Industry Association. So what these institutions or associations did, they actually combined hand together to actually come up with some sort of standards, and they named those standards. Name those standards. So the cabling standards are actually called 570A standards. So that's why we are calling ANSI / TIA / EIA 570A. Do you need to remember all of that? Maybe not, but just remember that all of the cabling standards come under 570A. So this was just like a small tinker for the overview. As for the topic, let's try to cover what are the different grades of the cables. So here we are going to talk grades of cables. Here we are going to talk about what different type of cables are actually used in residential structured cabling system. You will hear this fancy word again sometimes, RS, CS. It's nothing but it's called residential structured cabling system. So whatever we are talking about here in C7 certification, most of the time they are actually referred to as residential structured cabling system, but it is valid for commercial applications as well. So RSCS is residential structured cabling system. Let's talk about the grade of cables available. So we basically, in all of these infrastructures or structured cabling system, we create or we use 4 type of cables and 4 type of different cables, and all of these cables are used for different purposes. So most of the time you will hear that is it data, is it voice, or is it video. So these are the 3 type of medias, not exactly media, this type of data, what we call it, we need to actually transmit over these wires. So based on what we need to transmit through these medias, we need to actually pick up those type of cables. So let's start with a very, very common type of cable, which is called 4-pair cable. In a very basic sense, it's called 4-pair cables. So what does actually it means? If you go in the field, probably you will see that there is in the cable what we normally call it, it's a jacket, means it's a sleeve, and in this we have actually 4 cables going like this. And I will tell you why I'm drawing like this later on, and that will actually make sense to you. So here you saw that we have jacket here, it's called GACKET, jacket, and this is actually called 1 pair, 2 pair, 3 pair, 4 pair, 1, 2, 3, 4, but if you try to see, it's 1 like this. So 1, 2, 3, 4, 5, 6, 7, 8. So there are actually total 8 cables, which are called 4 pairs, and that is the reason that it is called a 4-pair cable. So here, what they do is they actually run these wires and twist them together. So twisting them together means actually like this. It goes like this, right? So it's 1 and 2, and they collectively are called 1 pair, right? So that's why they are called twisted pair also. Twisted pair or twisted pairs. Twisted pair, twisted pairs with a S, right? They actually they have a resistance of 100 ohms. 100, we actually designate the symbol by ohms, is actually called the resistance. Just remember this word 100. And in this 4-pair cables, we have been calling them like different names, starting from the last like probably more than 18-20 years. They are also called category X cables. So when we say category X cables, it could mean that category 3 cables or Cat 5 cable or category 5E cable. Sometimes these days you have category 6 cables also and category 6E cables also available in the market. But all of these cables, they are actually 4-pair cables. It means you have total 4 pairs and total 8 wires into it. Why do we call them category 3, category 5, category 5E, category 6 or category 6E cables? Is actually the amount of data which can be transferred through these cables. Category 6 is obviously less capable, so the total bandwidth what we can transfer over the category 3 cables is lesser than category 5, is lesser than 5E, 6 and 6E. So these days if you see, most of the time all of these structured cabling structures could be on category 6 and category 6E because they are able to transmit for more than 1 gig of data on the wires. So this is a 4-pair 100 ohm category 3, category 5, category 5E cabling media. They also actually come under a standard, what I call about ANSI, TIA, EIA. If you want to remember, it's not important, but it's 568 B2 standard. I'm just writing it here, but it is not really important. Let's go to the second type of media which is available. So the first one is 4-pair cables. The second type of media what we use is actually the coax media. It's also called coaxial cables. So coax cable, before I actually go there, so a normal question which could be asked actually in the field, or you might actually wonder, what type of information we can transfer over category X cables. So category 3, category 5, and all of those CAT, which stands with CAT, are capable of transmitting video, voice, and data, all three of them. So if there is a setup where you actually need to use maybe camera systems, yes, there is a possibility that you will be able to use the category cables, category X cables. If you want to transmit a data, where it is most commonly used, you can use category cables, category X cables. Where you want to transmit the voice, these days voice over IP mainly, or maybe digital or analog traditional voice, you can also use category cables. Why I did mention that? Because all of the other cables, they have certain limitations and we use them for very specific purposes. So starting with coax, as you might have seen in your homes, most of the time you have a small connector in the back of the TV, or maybe an HD system or a theater system. It looks like something like this, like a small hole with a dot in between, and it's a thick black cable like this. Some of you guys might have had experience in actually crimping those cables or putting the connectors behind them. So they look like something like when you take them out, there's a small aluminum foil here, and you will see like a plastic core here, and then there's like only one single copper wire which is coming out of there. So let me mention it. It's copper, COPPER. This is again a jacket. Jacket is nothing but a cover. This is the aluminum foil, which is also used as a conductor. Here you have an aluminum foil again, and this is like a plastic cover. So this is nothing but a coax cable. There are standards behind it. What we call them is series. It's not CAT. We call it series. Most of the time they are series 6 cables or series 11 cables. And the resistance for these cables is 75 ohms. The resistance on these cables is 75 ohms. That's all you need to know. It's not much significant here. So again, coax cable, 75 ohms. They are covered under a standard. I don't know if it is really important, but SCTE PSSP001 is the standard. No need to remember, but this is what the standard it is actually undercovered. What else? We will talk about the termination of these cables later on, but this is what you need to remember right now, that this is one of the cabling media. Where it is actually used most of the time, you will see there are special purposes. You might have seen that your cable company actually drop these cables. They are capable of transferring video as well as voice as well as data. Because for example, Charter or Comcast, it used to be Time Warner, all of these cables, all of these cable companies, they actually offer all of these three services. You might have seen for the voice, they might say, hey, you know what, we are offering a voice over IP system for $19 a month. They will say, okay, you have internet available as a package, and also you are able to see your TV channels. So that is a video. So the coax cable is also capable of actually delivering all of these services. Likewise in the category X cable media. Hopefully it is clear. Let's go to another media, which is which has more relevance these days and have been used more frequently. There are two types of cables in that, but let's start with the third one. It's called fiber cables. Or they are also called optical fiber cables. Sorry, I spelled it wrong. It's FIBER, fiber cables. So these actually come in two different flavors. We call it single mode fiber, single mode, and also we call them multi-mode cable. So fiber cable come in like two different flavors: single mode and multi-mode cable. Single mode doesn't mean that it has only one strand. So basically the science behind it is, again, you have a jacket, you might or might not have some sort of shielding. Then there is actually a plastic core, and in the plastic core there is actually an optical cable which actually goes like this. So again, it's a jacket. Then they have an optical media. So let's draw it again probably. I think this will make more sense to you, like something like this. Or something like that. So this is the jacket. And I was wrong that there is nothing actually in between. This plastic core is actually called cladding. From here to here. And this one is the optical cable. So there is only one strand or one single wire, but that doesn't mean that it's a single mode. So they actually come in different flavors. This is one of the flavors. The other flavors you will see is it is like this. This doesn't mean that it's a multi-mode fiber. It is just that the single pair of the single optical cable is put together into a group, also called strands. I will tell you why they are actually used, but they actually come into different type of fibers. So how do we decide it's a single mode fiber or a multi-mode fiber? So based on the core, what we call it core, and the cladding, measurements, we differentiate between a single mode and a multi-mode fiber cable. So in a single mode fiber cable, all you need to remember is, probably we can go here, single mode and multi-mode. In single mode, you have 50/125 micron meter, and here we have 62.5/125 micrometer. And I'm wrong here, so I need to remove this. So in the multi-mode, we have two flavors. One is 50/125 micrometer, and also 62.5/125 micrometer. And in the single mode fiber, we have 8.3/125 micrometer. So if somebody asks what is the difference, you need not to scare him with the numbers, but you can, for your own knowledge sake, you will know that a single mode fiber has a smaller core, and multi-mode fibers, they have a bigger core and cladding. So the outer shield is pretty much the same for all three type of cables. So why we use single mode fiber cables or multi-mode fiber cables over each other is there are a couple of differences. The major difference between both of the cabling is where you will use where the distance is more relevant. So single mode fibers are actually used to transfer to longer distances, and multi-mode fiber cables are used to transfer to a shorter distances. So all you need to remember is longer distances and shorter distances. Then there are different type of connectors, which we will actually discuss in the later session of this chapter. Let's go to the fourth one, which is also the last one. We call it high quality audio cables. High quality audio cables. A very good example of this one is speaker systems or home theater systems, which you guys might be going and installing. So speaker cables, they actually come in different different thicknesses, what we call it, and there is a standard called AWG. Yeah, looks very fancy. It's called American Wire Gauge Standards. American Wire Gauge, GUA gauge standards. So you will see terms like AWG, 14 AWG to 16 AWG. Then you will see 22 AWG. When you go to the stores, you might need to order these specific type of cables, and 18 AWGs. AWGs is also related to the thickness of the wire in the standard measurements. So 14 to 16 is actually 1.6 mm cable. 22 AWG is 0.64 mm cable, and 18 AWG is around 1.0 mm. So bigger the number, the thickness is less. So if you're ordering 22 AWG cable, means it is thick. It's thin, sorry, it's thin, and the smaller the number, the thicker the cable is. So 14 AWG will be thicker than 18 and will be thicker than 22 as well. So most of the time, these AWGs are also related with the type of pairs. So if you have 2 to 4 conductors in this, you will have 2 to 4 conductors, means you have a jacket and you have like a single 1, 2, 3, 4, right? And these are not twisted pairs, so they are not twisted like we were talking about like this, right? So these are like standard poles, and 2 to 4 conductors are in 14 AWG to 16 AWG cabling media. In 22 AWG, we have up to 4 to 6 conductors, and in 18 AWG, we have again 2 to 4 conductors. And these cables are actually used for speaker systems.